Hello class, so today the first thing I want to start off with, I forgot to put this up, but these are the problems in your book that correspond to each lesson. So if you're wanting to get some extra practice, then you'll want to go back and look at each of these sets of problems. Now you can see some sets are bigger than others. Sometimes we'll do some of this practice in class, but this is always a good reference for studying for the test. And I would suggest maybe going and just making sure you can do a few of these problems each day after you watch the video, just to see how things are going. And you're always free to ask me questions about any of these problems also in class. So today we're going to be looking at utilizing fundamental identities. You've already watched a video where we talk about what an identity is and defined reciprocals and quotients, just in case you don't remember. But now that you've watched that, you're ready to take your foldable. You might be a little bit confused on how to fold it at first, so just lay it like this where it's all upright, and then you fold the top down and the bottom up. And now you're ready to go. And I'm sorry for those of you who are OCD, but my lines don't perfectly match up. So really this is just a reference foldable. There's not a lot of work to be done in here. What we're going to do first is just go over what these identities are. Reciprocal identities just mean that sign is equal to its reciprocal under 1. Now, if we think about this, this really makes sense. We can write this down below in just a moment. Actually, let's go ahead. Let's do it now. So this first one is sine of theta equals 1 over cosecant of theta. So hopefully by now, I'm writing this down below. Hopefully by now you realize that sine of theta is equal to opposite over hypotenuse. Okay, and then on the other side of this, we're trying to say that this is equal to 1 over cosecant of theta. So let's see what 1 over cosecant of theta equals. Well, cosecant itself is just the reciprocal of sine. So cosecant of theta is hypotenuse over opposite, and all that's under 1. Well, here we have a complex fraction. We learned in Algebra 2 that to change a complex fraction, we keep the top the same. This was known as stay switch switch. Division became multiplication, and you flipped the bottom fraction, so it switched. And 1 times anything is just itself. And now you see that 1 over cosecant of theta is equal to opposite over hypotenuse. Well, opposite over hypotenuse is equal to sine of theta. So, in a roundabout way, this can be proven. Okay, this makes sense. And all the other reciprocal identities that you see here work in a similar fashion. The reason why these are useful is later we'll be verifying identities, and when you see a cosecant theta in the denominator, you can automatically change it to a sine theta in the numerator. And that's allowed because of these identities. The quotient identities, these you'll run into a lot more actually than the reciprocal identities. This one is a big deal. Okay, we're going to use it right off the bat in this very lesson. Tangent of theta is equal to sine theta over cosine theta. And this works in a similar fashion as the one that we just did. If we want to prove it, let's do that down here. So let's start with the right hand side and work our way to the left. So we're going to say sine of theta over cosine of theta, and we want to prove that's equal to tangent. Well, let's change sine into opposite over hypotenuse. And let's change cosine to adjacent over hypotenuse, because those are the ratios that they're equal to. Well, we have another complex fraction, so that the top stays the same. The sign switches to multiplication, and the bottom switches to its reciprocal. So whatever your hypotenuse is going to be, whatever number, it's going to cancel regardless. And then you end up with opposite over adjacent. Opposite over adjacent, so it should look familiar. That's tangent of theta. So there you kind of see why these identities work. And these are kind of, I talked last year in Algebra 2 about proofs. These aren't good proofs, but they get the gist of how two things are equal. So now, if you haven't done so already, go ahead and glue this in. In my next video, I'm going to talk through some actual examples of what we're going to do with these identities.